In this video, I'm going to help you with the post-lab assignment for Lab 3, Le Chatelier's principle. First question, you're just going to write an equilibrium expression for the reaction that you performed in part 1. In question number 2, you have a data table, and in this column, you will have recorded the observed color for each one of these test tubes. These are not the colors that you're going to be observing. I just made them up. And then in this last column, you are going to be predicting the equilibrium shift for each one of these test tubes. Now, the control with no stress to the system reflects a system that has no shift to its equilibrium. And the observed color yellow, we know from our observation that the observed color yellow corresponds to no shift. We have to decide if the observed color blue corresponds to a shift to the left or to the right. We know that it's not no shift because we know that that would be a color yellow. The way that we're going to figure this out is take a look at what we did to that system and then just compare that to the balanced equation. Now, one of the tricky parts about this is that all of these substances are written in their ionic compound form. For example, FeNO3, and we have to keep in mind that FeNO3 contains the Fe3 plus ions and the NO3 minus ions. I'm going to do the same thing for the next, I'll do the same thing for the fourth one. That's the Ag plus ion and the NO3 minus ion. You are going to need to go through and identify the cation and anion in each one of these test tube number 3 and test tube number 4. So knowing that we are adding Fe3 plus and also NO3 minus, what we want to do is look at our balanced equation and we want to see which one of these two substances is actually in the equation. It's Fe3 plus. So when we add Fe3 plus to the system, we're adding one of the reactants. And Le Chatelier's principle tells us that that's going to cause the position of equilibrium to shift to the right. So I'm going to make a note of this right here. We know because we added a reactant, the position of equilibrium is shifting to the right. Now, we also just figured out when we did this that anytime we see the color blue, that corresponds to a shift to the right. So that tells us that test tube number 3 also shifted to the right. And we don't even really have to look at the equation anymore. For test tube number 4, it turned red. We know that it did not shift, that would be yellow. It didn't shift to the right, that would be blue. So that means that these 3 must have shifted to the left. Now we're going to move on to question number 3, and this is really the tricky part of the post-lab. In question number 3, you've got test tubes 2 through 6, and you need to identify, by checking one box per row, identify what caused each observed shift in equilibrium. So first thing I'm going to do is just sort of copy which direction did it shift. We have a right, right, left, left, left. So I'm just kind of make a note of that. This shifted to the right, and these 3 shifted to the left. That's just for my reference. Now, the next thing that I'm going to do is take a look at this equation, and I'm going to use Le Chatelier's principle as much as possible to help me also predict whether each one of these different stressors would shift to the right or shift to the left, cause a shift to the right or the left. For example, if we add Fe3 plus, adding a reactant, we would shift to the right. So this would correspond to the shift to the right, and the opposite, removing Fe3 plus, would cause a shift to the left. Adding SCN would cause a shift to the right, removing it would cause a shift to the left. Adding FeSCN2 plus would cause a shift. If we added this, it would cause a shift to the left. So the opposite would cause a shift to the right. Now, in terms of exo and endothermic yet, we haven't figured that out yet. So this part we don't know yet. So for test tube number 1, we know that the position of equilibrium shifted to the right. So we also know that that means we will not be selecting any one of these boxes that correspond a shift to the left. Test tube, I'm sorry, I said number 1, test tube number 2. Test tube number 2 shifted to the right, which means we need to be selecting one of these stressors that corresponds to a shift to the right. And the same with this guy down here. For test tube number 4 and 5, shifting to the left, we know that we need to be selecting a stressor that corresponds to a shift to the left. So I'm going to cross these out. And test tube number 6, this is the one where we heated up the test tube. That's the one where heat was our stressor. And so since that one has to do with heat, we know that we're going to be selecting either exothermic or endothermic. So we've got this data table a little bit narrowed down. Now, for test tube number 2, this was the reaction where we added Fe3+. So this one's pretty easy to figure out. And test tube number 3 is going to be pretty easy for you to figure out as well, because test tube number 3 contained or added one of the 3 components that's featured in the balanced equation. Test tube number 4 and 5 are going to be harder to figure out because in those reactions, you added substances, I'm going to just copy this, that are not present in the balanced equation. So for test tube number 4, I'm going to stick it right here, we added Ag plus and NO3 minus. And Ag plus is not in our balanced equation, and NO3 minus is also not in our balanced equation. But we've got to figure out, we've got to choose one of these boxes right here. That means that Ag plus or NO3 minus interacts with one of the molecules in the balanced equation. Now, what could happen, what does happen in a situation like this, is that one of the substances that we're adding reacts with one of the substances that's already present in the equilibrium, and it causes that substance to be removed as a solid. So it just kind of removes it completely from the system. Now, I've circled Ag plus and Fe3 plus, and that is not what's happening. I'm just using that as an example. That is not what it's doing, but it's something along those lines. So you need to explore every possible combination. Is Ag plus interacting with Fe3 plus, or is Ag plus interacting with SCN minus, or is Ag plus interacting with FeSCN2 minus, or is it the nitrate interacting with the iron, or the nitrate interacting with the SCN? If you decide that the Ag plus is interacting with the Fe3 plus, then you would choose this box right here. The Ag plus is interacting with the Fe3 plus, which is causing it to be removed from the system. Now, how are you going to decide which one of these combinations is what's actually going on? The best place to look would be solubility rules, not necessarily the ones that are in your textbook because those are probably pretty comprehensive, but just looking up solubility rules on the internet, or even just Googling Ag plus reacting with Fe3 plus, or does Ag plus precipitate Fe3 plus, or does Ag plus form a compound with Fe3 plus, and you should be able to figure it out. You've only got 2 of those to do, so I know you can do it. Now, this last one down here, exothermic versus endothermic. We don't know if this reaction is exothermic or endothermic, but you are going to take your observed shift in equilibrium. And again, keep in mind that this is just hypothetical. This is not the right, right, left, left, left. This is not necessarily what you're going to observe. I just made these up. If the position of equilibrium shifts to the left, then what do you know about exothermic versus endothermic and shifting to the left versus shifting to the right? You're going to want to look at your notes, and because this one is a difficult thing to analyze. So what you want to do is look at your notes and say, look at if the reaction is exothermic and I add heat. So I'm going to write that down. If the reaction is exothermic plus heat, which way will it shift? Will it shift to the left or will it shift to the right? And see if that's consistent with what you observed. Also look at the same thing for endo. If the reaction is endothermic and I add heat, which way will it shift? Will it shift to the left or will it shift to the right? You know that it shifted to the left. Again, this is hypothetical data. This isn't what you actually got. So you're going to find the statement that is consistent with what you observed, and you'll use that to check one of these boxes. And you're going to do the same thing again for the second reaction with cobalt and chloride. However, this one is significantly easier. There are only 2 stresses that you did to the system, so you don't quite have to deal with as much, but you're going to use the same strategy again. This HCl, this is a source of H plus and Cl minus, and we have Cl present in the system, so you're going to be able to use this to make some to draw some conclusions about the colors that you observed corresponding with left or right. And then once you get that figured out, you're going to go over here and do a similar data table, checking 1 box per row. Maybe you want to start with this one because this one might be a little bit easier. But if you can get yourself through this, then you should have no problem with finishing the rest of the assignment.